All right, so let's see this particular question now. So in this question, we are given a string S, right? And it consists of only lowercase Latin letters. What we need to do is we need to return the first non-repeating character from this string S, right? And if there is no non-repeating character at all, we can just return the symbol dollar, right? The character dollar. For example, in this particular input string, race car, RACECAR, if you observe, E is the first non-repeating character in this entire string if we parse the string from left to right, right? So R actually repeats over here, A also repeats, C also repeats, and E is actually the first character which does not repeat, right? So we have to return that first character which is non-repeating in this entire string, right? So now maybe you can just pause this video and try to think of a solution. And once you are done, you can just come back and check the solution here. Okay, so now to solve this particular question, see there are various approaches, right? You can have two for loops and then for every character starting from the beginning, you can actually traverse the entire rest of the elements and check if that particular character appears or not. But that will be having nested loops and the time complexity will be order of n square, right? So that is not the efficient approach. If we talk about other approaches, there can be again multiple approaches, but the one approach that we are going to talk about is using a visited array, right? And this visited array is nothing but it's like a constant size array, which whose size is equal to the maximum ASCII value of a lowercase character, lowercase English character, right? So we can maintain that array over here. So what we can do is we can traverse this entire input array from left to the right, and at every index, what we can do is whatever character we have at that particular index, we can convert that particular element to its equivalent ASCII value, and then we can go to the equivalent index in that visited array, basically at that particular index, which is equal to the ASCII value of the current element, and we can just we can just flag that we have seen this particular, element, and we can just actually, update that particular index in the visited array over here to the index of this particular character as it appears over here in the input string, right? So what I mean to say is, let me actually write it over here. That way it will be better for you to visualize. So for example, this is my, the visited array that I have initialized, and I will initialize all the elements of this particular visited array to -1 to begin with, right? So for example, this is, entirely the visited array. And see the maximum value of the ASCII code that we can get for any lowercase English character is 122, right? So we can just have an array of size 122 and we can initialize all the elements to -1, right? Now, as we are traversing this particular array, at every element, I will convert that element to its ASCII code, and I will go to that particular index over here in the visited array and just update, the index of this particular element in the input array over here, right, at that index in the visited array. So for example, let's say this is that index, right, for this particular character. If I convert it into the ASCII code, for example, this is the equivalent index in the visited array, right? So what I will now do is I will just update it to 0, right, because it appears at the 0th index. Now, for example, A, right? So for example, A is over here, right? If I convert it into the ASCII value, it will be 97. So for example, 97 is over here, right? Let's say, I mean, this is just an example, right? So for example, this is the 97th index. I can also put maybe more zeros over here, right? And now I will just update it to 1, right? And maybe I can just, for, clarity, I will put the 0 over here somewhere, right? So that you don't get confused, right? So we have 1 over here corresponding to the A, and for R we have a 0 over here, right? And then C, right? So C will be over here, right? So I will just update the index of the C. So that is 2, right? And then I get an E, right? So E will again be somewhere, maybe let's say over here. So I will just update 3 over here, right? And then what I will do is I will go to the next element, and now I got C again, right? But I see that C is already like the position, the ASCII value index of, this character C is already like updated, right? Which would mean that I have already seen this particular element. So now what I will do is I will just convert this 2, which was the actual index of that particular character, to -2 this time, right? Why -2? Just to actually indicate that I have already seen this particular element twice now, right? That's why I'm just differentiating that. To differentiate that, I'm just updating it to -2 over here. And that's what I will do for every element that I'm seeing twice. Now when I go to A, again I will see that A I have already seen over here. So now I will just update, this particular index, which is equal to the ASCII value of the character A to -2, indicating again that I have seen this character, right? Now if I go to R, again I will go to the corresponding ASCII value index of this particular character in the visited array. I will see that it has already been updated to the actual, index, right? That means I'm seeing it twice, so I will again update it to -2, right? And how will I come to know, first of all, like if I'm visiting this particular array, then how will I actually come to know whether I have seen this particular element before or not, right? I will just come to know by checking the current value of that particular index, which is equal to the ASCII value of that particular character. If it is anything other than -1 or -2, that means I have seen that particular array, right? That particular element, right? Even if it is -2, that means I've seen it twice before, right? So anything other than -1 would mean that that particular character I have already uh, seen before, right? So that's how we will interpret this. And now what we will do is, once we have updated this particular visited array with the corresponding indexes, or with -2s for each of the character over here, we can just parse this constant size array, right? So this will be of fixed size, which will be of 122, right? Which is the maximum value of the ASCII code that I can get for any lowercase character. And now I can just parse this once, right, from left to right, and then whichever is the minimum value that I get from this particular string, other than -1 and -2, of course, whichever value is greater than 0, greater than or equal to 0, that I get in this particular visited array, that will be the minimum index at which a non-repeating character is appearing, right, in this particular array. So that will be my first non-repeating character, right? So, and then I can just take that particular index value and get the corresponding element from this particular string at that particular index and return that as the output, right? That's essentially what I'm going to do, right? And for example, if there is no non-repeating character at all, for example, all the numbers are actually less than 0, right, over here in the visited array, which would essentially mean that I was not able to update the actual index of any element, right? Because I mean they were appearing twice, right? Or more than once, basically, right? So that's why I was not able to update the actual index of any element in this visited array, and that's why there is no non-repeating character in this particular input array, and so I can just return a dollar character, right? So that's essentially the approach that I'm going to follow. And now if you talk about the time complexity, I'm just traversing this particular input array once, right? And later on, I'm just traversing this visited array. Now, this visited array is not like dependent on the number of characters in my input array, because it will be always of fixed size, right? 122. So that's why, the time complexity will be order of n. It will be linear time. And talking about the space complexity, it will be order of 1, right? Because again, I'm not using any extra space, which is like dependent on the size of the input, right? I'm just using a constant size over here, right? So like order of constant would be order of 1 essentially, right? That's why space complexity is order of 1 over here, since I'm just using a fixed size array of 122 over here, and time complexity will be order of n, right? So that's the entire approach. Now maybe we can just jump to our IDE and code this solution together. So, let me first of all declare, a function. I can just call it as non-repeating character, like this, right? And this will actually accept a string, right? I can name it as s. And now what I will do is I will first of all take the length of this particular string in variable n, right? And now I will just initialize my visited array, right? Like this. So it will be all -1, and the size of this will be 123, right? And now why 123 and not 122? Now the maximum ASCII code value of any lowercase character is 122, but to get 122 as an index in this particular array, I will have to actually make it of size 123, right? Because the indexes of an array starts from 0, right? So essentially, if I actually declare an array of size 123, then the last index of that particular array will be 122, right? Which is the maximum value of the ASCII code for the lowercase characters, right? That's why I have to just take care of that small thing by actually declaring it of size 123, right? So that's about that. And now what I will do is I will simply, parse the given input array. So I will go from uh, for I in range n, right? And then I will just check, if I have not already seen, the character, this particular character before or not, right? And how I will check that is I will just calculate first of all the ASCII value of this particular current character, and the way to do that is using the ORD function in Python. I can get the ASCII value of any given character. So I will get the ASCII value of the current character, and I will just index that particular ASCII value in the visited array, and I will just check, right? If it is equal to -1, that means I haven't seen this particular character before. So then what I will do is I will just update this particular value, right, to the actual index, right, of the character in the input array, right? So that will be I. And if that is not the case, if the current value at this particular index is not equal to -1, then what I will do is I will just first of all check if then the visited uh, array at this particular index has value greater than or equal to 0. That means some actual index, right, of this particular character. Then what I will do is I will just update this particular index to -2, right? Which means I have already seen this particular element before, and so now I'm just flagging it as seen more than once, right? By updating it to -2, right? So that's what I will keep doing for all the elements in the given input array. And then once I'm done, now what I have to do is I have to parse this visited array to find the minimum value other than -1 and -2, right? So for doing that, I will just declare a variable over here called minimum index, right? Like this. And I will just initialize it to n, which is nothing but the length of this entire string, which is one greater than the last index of this particular string s, input string s, right? That's what I will do. And then what I will do is I will go through all the elements of this visited array like this, right? So this will be now the actual element itself, the current element in this visited array, right? So that's what I'm doing. And then I will check if my I is actually greater than equal to 0. That means it is anything other than -1 and 0. -1 and -2, I'm sorry, if it is greater than equal to 0. That means it has an actual index. And so I will just reinitialize my minimum index variable with the minimum value between the current min index value, right, and the current element that I got over here, which is greater than or equal to 0, right? Whichever is the minimum of the two, I will just reinitialize to the minimum index variable like this, right? And at the end, if my minimum index, this one, is now actually lesser than n, which was actually the default value of the minimum index that we assigned. If it is lesser than n, that means it has got some actual index, right? That will be the character at that particular index in the input array would actually be the first non-repeating character, right? Because corresponding to that character, I got the minimum index, right? Out of all the indexes that I updated. So that means minimum index means, it appears first, right, in the input array, right? So that's why, if I just take the corresponding character at this particular index from the string s, that will give me the first character, first such character that is non-repeating, that only appears once, right? So that's why this, and if this condition is not true, if minimum index is actually equal to n only after visiting the entire array, it would mean that I did not see any non-negative element in this particular array, right, in the visited array, and so there was no, element whose actual index is updated in the visited array, which means that all the elements in this particular input array are actually repeated more than once, right? So that means there is no non-repeating character, and I will just return, a dollar character over here like this. So this is the entire solution. I hope you understood it well, right? Again, the time complexity is order of n. We are just traversing the input array once, right? And then we are traversing the visited array, which is visited is again like of constant size. It is not dependent on the size of the input. So that's why it is of constant time complexity parsing this particular visited array. Only thing that we are parsing is the input string, which will be of order of n. So the overall time complexity will be big O of n. and the space complexity will be order of 1 because it will be constant space basically, because again with this visited array which we are using additionally is again not dependent on the size of the input itself. It is always of the fixed size of constant size, that is 123, right? So that's why the space complexity will be order of 1, right? So I hope you understood the approach well, and now I will see you in the next video. Thank you.